Thank you very much. So we're going to talk to you today about the work we've been doing on medical device integration as part of the whole programme we've got, which is our e-hospital programme. I'm going to start with just giving you a little bit of overview about the organisation. So we are Cambridge University Hospitals. We are two hospitals under one umbrella. Addenbrooke's is the more well-known and Rosie is our maternity unit. We've got around 1,000 beds, but clearly that changes given winter pressures and time, and over 9,000 staff that work with us. We have a fully integrated EPR, and 99% of our documentation and the way that we work is recorded within that single system. We actually make any changes and integrate different systems into that ourselves with support of Epic. We've worked really hard to create a robust digital environment. Clearly the EPR is at the heart of what we do. We've tried to use the latest technology. We've done that and enabled ourselves to release time to care, so more time for bedside nursing. The clinical teams can all review the same thing at the same time, no matter where they might be, and on a range of different devices to enable that. We also have medical device integration predominantly within our theatre units and our high dependency critical care units, of which there are 148 high dependency beds and 40 theatres. I'm now going to hand you over to Herbert, who's going to talk to you about the work we've been doing on device integration.
Okay, thank you, Helen. Now, to set the scene at Cambridge University, when we decided to go for an EPR, we also decided to integrate as many medical devices as possible, and to differentiate what we mean with medical devices. We decided to go for patient monitors, ventilators, anesthesia cards, and cardiac output monitors initially in any high dependency or intensive care area, as well as the entire theaters. Infusion devices, hemofiltration devices, nitric oxide, or any other devices were excluded for initial go live just because we wanted to focus on the main workload of especially nursing staff, and we wanted to keep, of course, complexity to a minimum. Not included in the medical device integration work stream were from the beginning any point of care devices or the pathology interfaces. They, of course, were integrated as well, but through different routes in our EPR system. Of course, you could theoretically also integrate, for example, urine analysis at the bed space or in a point of care lab into the medical device integration stream. But we decided, as we have point of care integration engines as well, to do this in a separate work stream. Thanks. Now, to look a bit more closer what you can do with medical device integration in general. Now, we have chosen Capsule Tech, a company of the Qualcomm family, as our preferred integration provider. And here you can see basically the integration options in high dependency and intensive care. Generally, they are fixed solutions, like through concentrators, either by a neuron, an axon, which is the a concentrator which has no ability to choose the patient, but was our preferred solution, as we could do the patient to data matching in our EPR solution. There's also a client version which we use currently in anesthesia. What is more popular now, especially with infusion devices and monitoring in low acuity areas, is a monitor gateway solution, which we are currently preparing. There are many other solutions as well, especially the IV solution I will come later to, because that's a little bit problematic in the UK yet. Now, basically all data from devices is collected at the bedside or in theaters from the anesthesia card and fed into the Trust network. Of course, for security reason, we're using a VLAN, so a VPN network within our Trust network environment. This data then is fed into the Smart Links client. Smart Links is basically the solution from Capsule Tech. And from there, it goes directly into our EPR system, which is EPIC at Cambridge University Hospital. Now, there are future options we want to look at, and I will show on a later slide. For example, also home monitoring would be theoretically possible. Now, next slide. Now to look a little bit more closer, so our two main medical device integration solutions in anesthesia was to use a software version. Here there's no concentrator needed. On every anesthesia card we have a PC, of course, for the anesthetist, a big screen, and the client version from Capsule Tech, which is SmartLinks client, installed. So every device on the anesthesia card is feeding into the PC via standard serial connectivity. The client will pick up this data, transform it in a HL7 message, and send it to the server, where there is then the matching happening in our EPR system. So far we have connected anesthesia cards, of course the monitoring part, the ventilator part, and we are now just rolling out additional monitoring like cardiac monitoring on the anesthesia cards as well. In critical care, we are using at the moment, blank this out, axons. We have not chosen to use the neurons because we are matching the patient to the data in our EPR system. That will change once we will roll out medical device integration in low acuity areas as well, where mobile devices are in use. Then, of course, the patient to data matching needs to happen on the device. So here we use, at the moment, axons to feed ventilator monitoring and all kinds of other specialist devices data into our EPR. We are preparing at the moment a gateway for monitoring to roll it out in the emergency department, cardiac units, all cardiac wards, and in our entire recovery areas. So theater recovery areas will also be connected via monitoring gateway. The benefit of that is there is no concentrator needed. And most of our monitors are already on a trust network for central monitoring at the nursing desk. We are just using this data basically and feed it into a gateway, and from there into the Capsule Tech solution. The client version at the moment is not in use in critical care, but will be rolled out in August because we want to use the client and the concentrator simultaneously to integrate some mobile devices, and I will show you later. Now, considerations for the infrastructure, and this is very important, is before any device integration is even considered, to reduce the number of device types. If you have 5 different monitoring device types in your trust or in your hospital, you will end up with quite significant workload because they have different drivers, they have to be built out differently, you need different cables for connectivity. So the device standardization is, I think, the first thing which needs to be looked at well before any implementation. Mounting solutions, that is a practical but also a financial impact, because mounting solutions are often quite pricey and difficult to facilitate in a clinical environment where infection control needs to be met and so on. The other issue is with mounting, I suggest if a device can be stationary, fix it, bolt it, make it unmovable. That is the best way of securing devices not disappearing, but also to make sure the information is going into the right patient's chart. As we are not matching patients at the bedside, we are matching them in our EPR solution. That's why it's important that our devices stay where they are. touchscreen versus keyboard and mouse. Now, all the clinicians love touchscreens, and they all wanted touchscreens everywhere. We tried not to use too many touchscreens, not only because of money, but the main reason is it's quite fiddly with lots of data entry and especially with operating in an EPR system. Now, in theaters on the anesthesia cards, we use touchscreens, and the reason is our EPR system has a special user interface for the anesthetist, which is touchscreen enabled with big buttons. But still, despite having touchscreens, we went for keyboards as well, because if you have a problem and then having to type in all the patient data, that can be quite laborious on a touchscreen. Screen sizes, big is beautiful, of course, as far as you can afford it and have the space. So we have standardized across the trust with 24 inches, which makes it then also easier for the anesthetist to actually hit the right button. Network access is very important. Device integration is not high on bandwidth. It doesn't need a lot of bandwidth because HL7 messages are very small, theoretically. But it needs good quality of service with the data. So you need to make that we don't want interruption in data gaps or connectivity gaps. That's also the reason why we went for wired connection, if possible. Yes, many devices have wireless capability, but wireless capability is much more unstable than a wired. So if possible, we went for wires. Network and server capability, of course, we have at the moment 2 servers running, one serving all the theaters and one serving all the intensive care and high dependency care environments. We will need another one because by setup of capsule text smart links, the server setup determines if you can handle mobile devices. That means when you need an ADT feed and send data out to mobile devices and get information back with patient data, the setup is different. So we will introduce another server once we go live with mobile devices. Licensing, we have quite a flexible agreement here. So we are on a bed space license. That means we're paying per bed space, and then also depending on how many devices. So if you have areas like our recovery or ED departments where you have maybe only one device to be connected, then one device per bed space license might be sensible. Otherwise, in intensive care, high dependency, we have a multi-device license. If you decide to go trust-wide live at some point, it might be sensible to think about a trust or site license, which is of course more expensive, but then you are free to do what you want. Support and help desk, that's for go live especially important, because usually an IT help desk gets calls for all kind of stuff, from unplugged devices until, my patient doesn't appear on the screen. When medical device integration issues are reported, the support staff at the help desk usually cannot identify this very easily, because staff will just tell, oh, my patient data is not there. That doesn't mean the help desk will easily pick up that's a medical device integration issue. So we developed actually some questions and answers for the help desk staff to figure out if it's a medical device integration issue or not. And that can help with dealing with the problems very quickly, because actually you need to route it to the right people, and medical device integration is a very specific part of the IT system. Project consideration. You need good and strong project management because there are lots of stakeholders involved. There's clinical engineering who look after devices. There's an infrastructure provider or the IT department who look after the network. You have the hardware people who look after the PCs and will do client installs. You will have the estates department, most likely, because you need equipment being put in, network ports, the concentrators need to be wall mounted. So there are lots of people involved, and then you have, of course, the medical device integration team, maybe the EPR team who need to look after where the data is actually going. So project management is key. Filtering of data is key as well, because the devices send thousands of data points. So the important thing is you want to narrow it down to what you actually need, what is required. Clinicians usually tell you in the beginning, oh, we want everything. That is a problem, not only because most data is not required. Second, the devices send data at a frequency which nobody needs, if you don't do research. But for clinical use, you want to actually reduce that significance. So we are taking reading every minute. So we have from every device 1 minute readings. And that has proven to be more than sufficient. Staff training, important, of course. I don't need to, I think, elaborate on that. Switchover process. Now we, as I think commonly known now in Cambridge, we did a big bang approach with everything. So we replaced IT, we replaced the EPR, we introduced MDI, and so on, which is, let's say, challenging for staff, especially when they come from a paper background. But overall, I have to say, the medical device integration part of our big bang, smooth. There was no problem. People just liked it, and they were a little bit surprised. Oh, God, data is there. Great, I don't need to type it. But overall, I think that was something we didn't worry too much at Go Live. Business continuity. Now, people get used to stuff very quickly. So once you have switched it on, when it doesn't work, people will miss it. They will very, very miss it. So you need to have a quite simple plan in place, and that is people, you can still enter the data manually as you did before. But that is something which needs to be reiterated. And it has, I think the only impact it has is in theaters, because there is the biggest saving of time for the anesthetist. So there you need to think about what will happen if your system is not available. Daylight saving time change, yes. As long as we have daylight saving time, we will have a problem. Not in April, in March, but in October, because in October you have 2 readings within 1 hour. So you need to come up with a plan how you eradicate that. So we usually at 2, is it 1 or 2? 1 o'clock in the morning we switch off, and at 1 o'clock we switch on again because the time goes back. So that's something to think about. Responsibilities, and I told about for the consideration, who is doing what, and you need clear guidelines, who is responsible for it. Not only that it is done, but also there's no overlap. So there need to be boundaries, who is responsible for what, because by experience, people want to do everything and like to take over other areas of other people. Workflow challenges we have experienced in critical care is the patient linkage. So that in our solution, as we do this in the EPR system, it is absolutely crucial that the patient is in the right bed space at the right time, because the data is assigned by a bed space. The concentrator sends the identification with the data, and the EPR matches it to the bed space. So bed management and patient flow is crucial in our solution. Manual data validation and verification. All data in critical care high dependency is in our EPR system. Once it is taken in from the medical device integration server, is non-validated. It means we keep it for 72 hours in our system, and it shows in a different color. And after 72 hours, we delete it. If nobody has validated it, basically verified, yes, that's a true reading, that is actually data which corresponds with the patient observation. And then it depends on the nurses. They can basically take every minute, or they take 1 hour on every half hour. It depends on the acuity. But generally, we give them the opportunity to validate data for every minute. They still can enter manually, of course. And other workflow challenges were mobile equipment dim mounting. Now, the issue is ventilators, for example, are not fixed. Monitors are usually fixed in these areas. Ventilator not, they move around. As a specialist monitors as well, they move around because you don't have a cardiac monitor for every bed space. Now, it's important that the identification of the device, and that's, we call it DIM, that's basically a little box where the identifier is in and it's attached to the machine, cannot be taken off because if this identifier moves around or gets detached from the device, you lose basically the MDI server will not know what device it is, or it will actually send the wrong information because we are identifying our devices through the system as well to know which patient was attached to which device at what at every single period of time. Now, we solved this solution. Now, I hate to say it, but most devices still use serial D-sub 9-pin connectors, which is, I know, very old technology, but it's the best technology when it comes to mounting because you can just put some torque screws in, and usually nurses don't carry torque drivers with them, so that's the best way to make sure it is fixed. In anesthesia, in the theaters, all our data is auto-filed. That means we're taking the information from within the card and file it directly into our EPR system. The anesthetist doesn't need to validate it. The reason here is just the workflow for the anesthetist. So they don't need to validate every minute what they see on the screen. We have done 4 go live. It's the only part, basically, which we went a little bit live before our big bang. We gave the anesthetist some time to shadow chart. We meant they did a normal charting on the paper before go live, and we switched a test system on for them where they can learn how to use it. Because if they weren't able to do this on go live, our theaters would have come to a standstill. Then we use induction rooms in Cambridge. That means patients are prepared for theater in a prep room before the theaters and then moved in. But we do also device integration in the prep room. So that was a challenge because we're using 2 different technologies. We have the client and the theater on the cart, and we have a concentrator in the induction room. So it was very important for the anesthetist to understand, as long as they don't stop data in the EPR, stop the data validation, they will not be able to switch it on the theaters because you can't feed from two areas into one chart. Yes, and manual entry here as well, of course. Now, benefits, and that's the thing every time I get asked when people come to Cambridge and look at our system, and they want to know, oh, what's the benefit of doing that? Because I need to go to my trust board and tell them I spent a lot of money on something. Now, we release time to care for nursing staff, especially nursing staff. We had a significant reduction in errors when it comes to data collection. Of course, if you manually chart, you are prone to write wrong stuff down. We have now much better data quality because if you have an automatic feed, of course, you have much more data available. And if you look at the paper chart in the past, you will have huge gaps because people just didn't have the time to write it down or forgot about it. In anesthesia, in theaters, actually the anesthetist can focus on the patient now. So especially during getting into the theater, getting out of theater. So preparing the patient for the surgeon, and then afterwards extubate the patient, wake the patient up. That is now much quicker because they can focus on the manual tasks in the patient instead of writing data down. So we have actually much more data here. And this has led to a shortening of actually the theater total times. So yes, the surgery itself is still the same time, but because of a shortening time of the introduction and the moving of the patient out of the theater, that has shortened the time, and we can now do more surgeries. It's a small amount per surgery, but overall, it's significant time. So we decrease the turnaround time. And across both areas, of course, data accuracy has significantly improved. We have actually now a track who was connected to which device. That's from a clinical engineering point of view quite interesting, because if we have a problem with a device, we can actually check who was connected to it. from incident reporting. We collect not only observation data, we collect also the alarm settings from the devices. So we know if a patient's monitor was set at which alarm and why did it not go off. Why has nobody attended the alarm? Because the alarm didn't go off, it was too low. We can prove this now. And we can actually look into how well is our equipment used. Very important for clinical engineering and of course for the finance department when we buy equipment, especially equipment which is mobile and used on several patients. And we can find devices, because every device has a serial. If I know the device serial, I just type it in my system and I can tell you in which bed space it is. Very good for clinical engineering to find the devices and picking them up. Okay. Now, that's basically a journey with medical device integration. We have this, thankfully, from Qualcomm, where you want to start and what you can achieve, basically. Now, we are definitely here. We are in the acute setting, and we have integrated a lot here. The next step is going to the post-acute care, which is also done by the hospital. We are planning to do this fairly soon. The ambulatory care, we think about using a mobile device within our clinic environments, especially in clinic environments where data is taken regularly from the patients. That could be cardiac clinics, that could be eye clinics, and I'll show you why we have special devices there. The next thing would be remote care. So basically, yeah, look, monitoring patients when they're at home, and we have lots of chronic patients, lots of patients which are seen in Cambridge on a regular basis, or patients which have specific needs. We have a module live in Cambridge which is called MyChart, and with that we hope in the future we'll be able to do some of the automated data feedback. And of course preventative care is that looking into wearables and other modern forms of technology which are around, but that is the future. Now at the moment, to sum it up, what we're doing this year, what we are expanding on is, of course, connectivity in the ED and cardiac service. That's imminent. Another big thing is our first mobile equipment, and that's we are measuring the pupils. Basically, we do this in neurocritical care and all intensive care areas, and we will integrate them by the consumable. So the consumable basically takes the data, the consumable stays at the bedside, is reused, the machine actually is used on every bed space, and the nurse just puts the consumable in an RFID reader, which is connected to the nurse station, to the computer at the bedside, and the data automatically flows in. Nothing else. Just put it on the RFID reader, and the whole reading of the eye is in the chart. And the other big thing, SmartLinks IQ, we want to basically introduce another solution from Capsule Tech, which sits on top of the MDI solution and takes additional data from the devices. That's for basically monitoring usage, battery status, firmware, software, and all this. We're doing this mainly for a better buy-in from the clinical engineering department, because that will help them to look after their devices.
We don't have that much time for questions, unfortunately, but if you want to carry on this conversation, we'll be having a break in 15 minutes after Emma's presentation, so we'll definitely catch up with you then. And if I can just invite to the stage then Emma Wright, and she's going to be talking... Oh, sorry, yes.